Just as we saw velocity was a change in displacement with time, acceleration is defined as being a change in velocity that occurs in some time period. So this can happen three basic ways. You could have an object speeding up, it could slow down, or it could change in its direction. And of course, it can be doing multiple of these things at the same time. Acceleration is a vector, just like velocity is, and we define the average acceleration as being the change in acceleration, delta v, which is defined as being the final velocity minus the initial velocity, divided by the change in time, or the final time minus some initial time. If we look at this equation for acceleration, we can see what the units of acceleration must be. We know that velocity is meters per second, or a distance that's traveled in some amount of time, and then time, of course, is seconds. So dimensional analysis tells us that the units of acceleration would be meters per second squared. If we make a graph of velocity versus time, then the acceleration will be the change in the velocity over time, or the slope of a straight line that connects the final and initial points of our motion. So if we think about the relationship between acceleration and time, we can see that the direction of the velocity vector and the direction of the acceleration vector are related to each other and depend on the motion of the object. So if you have an object that's speeding up, the velocity and the acceleration vectors point in the same direction, and the velocity and acceleration would have the same sign if the motion is in one direction. If, on the other hand, the object is slowing down, the velocity and the acceleration would be in the opposite direction and have opposite sign. So in this series of pictures, you can see a multi-flash image of a car that's moving. A multi-flash image is one where you pretend that an equal amount of time has passed between each one of these images. So with series A, you can see that the car is an equal distance in each subsequent image, implying that its velocity is constant. So it's traveling with zero acceleration. In the second image, you can see that the car is speeding up as there's greater and greater gaps between the images of the car as time goes on. So this means that if the velocity of the car is forward and it's increasing, and the acceleration is pointing in the same direction as the velocity, you can think of it as the acceleration vector adding additional velocity to our velocity vectors. On the other hand, if the car is slowing down, the velocity and the acceleration are in opposite directions. So you can think of the acceleration vector as nibbling away at the velocity vector and making it shorter, making the velocity smaller. So here's a question for you. If a car is traveling east, will its acceleration be eastward?